So, in the last class we stopped in actually come here now. Okay, so I am just starting. So, in the last class we stopped at we were trying to show that the we came to the final result that the total means we can keep the total draft without changing, provided we change the sinkage and the trim such that we can make them make the total equal to 0. Okay. Okay. Now, we will continue with that. We will come to what we call as a mean draft. So, the meaning of mean draft is, of course, that provided the vessel has some initial trim, it is some trim in the aft and the forward side. Suppose we make it even keel, or it is not that it is even keel, we talk about the trim at the midship. It is not really trim, you cannot call it trim, because it is not below some region or below above another region, it is really just a draft. So, that is called as a mean draft. Okay, we call that as the mean draft, it is not really trim in any way. So, we call that as a mean draft. Now, when you add a load to a vessel, you know that if the vessel is trimmed in some if the vessel is trimmed to some level, and if you add a load to it, let us suppose if the vessel is trimmed like this and you add a load here, and if the load is such that finally the vessel comes to even keel. Okay, even keel means like this in a horizontal state. Now, the thing is this even keel in this case will not be the average draft, means the mean, this is called the mean draft. Mean draft is the draft at the midship, it will not be equal to the average draft. What I am talking about as average draft is this draft plus this draft by 2, because this will sink also or go up. Okay. So, the mean draft in general, average draft means suppose you have some draft here, some draft here, and you add a load, you take the average of these two drafts, that is called as an average draft. Okay. So, the mean draft is slightly different from, becomes slightly different from the average draft because of parallel sinkage and rise. So, that is one point. Then we actually I just will assume that you remember this, that is we got an expression for change of trim and all that as L0C. There was a figure, I do not think I will draw the figure again, it is just the same one figure which showed that L0C means L0 L1 was there, which was put as C, then L0C is the, we called it as the, I think it is the change of trim, right, it became the change of trim of the vessel, change of trim. Now, let us define a small c as the difference between now when you write like this as a subscript, itself will tell you what it is. dA is draft aft, dm is draft midship, df is draft forward. Okay. So, it is, as the name itself suggests, it tells you what it is. Now, let us suppose that C is the difference between draft aft and draft midship, and just a minute, I think there is, I made one mistake. Actually, one small thing I say, it is not midship, it is actually the center of flotation. Okay. It is not midship. Okay. We, though it is maybe very close, but you cannot what is that, interchange the two, it is not, it cannot be said like that. So, its mean draft is actually the draft, though they have put it as M, it's the draft exactly at the center of flotation, because the vessel always trims not about midship, it trims about the center of flotation. Okay. So, that is very important. It's so this so that midpoint which we are thinking of, when there is an aft and there is a forward, we conceptually we think of as midpoint where it's that is actually the center of flotation, it's not the midship. Okay. So, L0C is the change of trim, and let us define small c as dA minus dm. Now, if you look back into the old figure, you can see it very directly in the text. You will see that there are two similar triangles come, okay, in that, as a result of which, if T is the total change of trim, okay, and C is the difference between draft aft and draft in the midship, or not midship, draft in the center of flotation F, then if L is the distance between, it becomes two similar triangles like this, okay, something like this, some two triangles come. So, C by L will become equal to, L is the distance from the aft perpendicular to the center of flotation, small l, L is the length of the ship, capital L, T is the total change of trim, and this is like the change of trim in one side. Between dA and dm, see, change of trim is always defined as the difference in draft, okay, between aft and forward. C is that between aft and midship, not between aft and forward, but between aft and midship. So, it is like one small triangle, half triangle, and one big triangle, and you are just saying they are similar, and you are drawing this equation. So, it automatically gives C is equal to L by L into T. So, C is again dm minus dA is equal to L by L into T, or dm is equal to L by dA plus L by L into T. Okay. So, this, oh, actually it's not like that, there is a mistake, it will be dA minus dm, because otherwise it will be negative. Midship will be actually, if the draft is like this, then midship will be above. So, dA minus dm will become like this. So, what will it become? dm will become dA minus L by L into T. Actually, it just depends. I mean, if it is like this, it will be other way around. You just, this you remember that this expression you can just look, we will see, do some problems, you will see, you can what do you call, change according to that particular problem, but this is fixed. Okay. C is equal to this is what should be added. This is the difference between the draft in the aft and the midpoint or the center of flotation, that we should be able to remember. Now, it's why it's said, means you might see a lot of the major part of this book, this chapter always deals with trimming by aft. You very means you very they have explicitly said, in the rare case of trimming by head, means that means it is a very rare case. That means a ship is never usually like this, it is always like this. Okay. If you look at any ship picture, you will see that. Carefully you check that next time when you see a, not big ships, not like a oil tanker or anything, there you will not see anything, it is too big. When you see small boats, okay, you check that it is always be like this, it will never be like this. Okay. It is because mostly because the weight is mostly in the back side. You even for a small boat, you put the engine on the back side, you have seen that, it is always at the back. So, it will always be like this. So, that is why it is always in this, they have automatically assumed that the draft in the aft is always down, forward is up. So, the middle will be somewhere in between, it is above the draft. That is why this definition, this it will become dA minus dm. Okay. So, in the unusual case of vessel being trimmed by the head, it will be this, it will be dA plus dA plus L by L into T. That is a very rare case, but in case it happens, that is the equation. Okay. Then okay, one problem is there. We are told that there is a vessel which is floating at a draft forward equals 10.8, draft aft is equal to, actually let us write it small d, draft aft is equal to 11.4, and it is said that it's now going to load things in it, and final loading, after loading it will have the draft forward equals 10.9 and draft aft 11.4. Oh, is the same thing. Okay, aft is not changed, aft is still at 11.4. Then TPC is something, and the length of the vessel is 138 meters, LCF is 65 meter from AP, and you are asked to find the total load or the cargo that it has to load. So, you are given the initial drafts, final drafts, and all these things, and you have to find the amount of weight load it has to, the amount of cargo it has to load, so that this initial and final condition holds true. Okay. Now, we can proceed like this. First of all, let us find the, as you can see, aft is below, okay, aft is 11.4, the other one is 10.9. So, it is like this only as the usual case. So, dm, just by applying the previous formula, it becomes T, okay, where T is the total change, total trim, change in trim, or the difference between the aft and forward. So, this only problem here is to know what each thing stands for. Draft aft is this 11.4, we are talking about the initial case. So, 11.4 minus L, you have to know each thing, that is I guess the only thing in this. L is the distance of the center of flotation from the aft perpendicular. So, that is given here. L is the length of the ship, and T, what is T here? It is the 11.4 minus 10.8, that is all. It is the difference between the two, forward and aft. So, if you just take the difference, you will get that, it is 0.6. Okay. So, this will give you something 11.117 meter. So, this is your mean draft, or this is the draft at your center of flotation. Okay. Now, then this is initially, okay, before loading has happened. Now, loading is done, and your final same things you do, same set of, you are given all the data, same data for your final case also. So, that will you have to do it, and you will get the final draft 164 meter. So, we have the initial and final drafts. Now, difference between them will give you what? That is what, actually you have gone even further than that. Actually, the difference between that will give you the sinkage. Okay. So, sinkage is equal to 11.164 minus 11.117. This will give you the sinkage. So, that much centimeter, okay, that much meters, that becomes 4.7 centimeters when you convert to centimeters. So, this is your sinkage, and as I said, the next step is, we know that the sinkage is always given by W by TPC. So, W by TPC is equal to this. That means, W is equal to TPC into this. TPC is given as 28 some into 4.7 centimeters. So, that much will give you in tons. Actually, these small things note, you in when you are doing W by TPC, you have to write your draft in centimeters, okay, not in meters, otherwise you will get divided by 100, something like that. So, difference will come. So, W by TPC is equal to 4.7, because TPC is always given for centimeter. One of its units is, it is like tons, what is it? TPC is given as tons per centimeter, yeah, tons per centimeter. Okay. So, 131.6 tons. Okay. Now, now as you can see, you can check one thing. if you just take an average draft, means see we have taken the mean draft, which is the draft at the center of flotation. If you take an average draft, actually you will get a difference, very small difference, but still a difference in the answer. Okay, it's a very small difference. It actually this will give you an answer of 131 and that will give you some 140. So, okay, some difference in answer. So, you have to always take the mean draft, because that will give you the exact, okay, that it will include the sinking everything, and so you have to take that. So, always take the mean draft and not the average. Do not just take aft plus forward by 2, you just use the formulas that are given here. Okay. Then another problem is, okay, so it is told that a vessel is floating at draft forward equals 11.48 and draft aft equals 12.26. Now, again, actually this is the same problem almost. Okay, slightly different. That is, in this it said that finally some loading is done and final drafts are draft forward is equal to 11.9 meters and draft aft is equal to 12.1 meters. Okay, so this now the difference here is cargo is loaded in this fashion. It is loaded in a compartment number 5, 30 meter forward of AP. So, compartment 1 is 30 meter forward of AP and compartment number 2 100 meter forward of AP. So, that means, are you given the total cargo? No, you are not given the cargo also. So, that means you have to find two things here. Then you are given a couple of these things, like MCTC is given 120 tons meter per centimeter. Then you are given the TPC 32 tons per centimeter. Then LCF is said to be 64 meter forward of AP. Then the length of the ship is 140 meter. Now, here what you have to find is, first you have to find the cargo that is to be loaded, total amount of weight that must be added. Number 2, you have to find how the cargo is to be distributed between the two loads, such that you get these final drafts. Okay, that slightly more complicated than the previous problem. Now, same thing, note that when you are doing parallel sinkage, in all these trim problems, when you are doing the parallel sinkage, when you are trying to find the W by TPC, always find that W by TPC is equal to something, right, that is always equal to the value at midship. Okay, means it is a sinkage of the center of flotation, not midship. I keep so it is always the difference in the position of the ship at the center of flotation, okay, or the drafts at the center of flotation. So, dm, so first the initial mean draft you have to find, which obviously means the draft at the center of flotation, dm is equal to d aft. This formula is anyway fixed, so you can do this. So, everything is given. Draft aft we know, the distance of the LCF from the center of flotation from the aft perpendicular, that is given there. Capital L is the length of the ship and T is the difference between the forward and aft, or aft and forward, aft minus forward. So, this I guess is only slightly confusing. The other things are fixed, L, L, D are all given. This, just know what this T stands for here, change in trim, forward draft minus backward draft, that is the change in trim. Okay. Okay. Then now you just do this, you will get something. Then same thing, you have to find, this is the initial mean draft. Then similarly you have to find the final mean draft. Same process applied for the final case. Then so the final draft minus the initial draft, dm initial. So this final, just do that, I am not doing it. So this draft minus this initial draft, which comes in this case as 0.106 meter. So this is your sinkage, parallel sinkage. That is, then we use the formula W by TPC is equal to this parallel sinkage. It is given in, so you have to write here as 10.6. So that will give you your parallel sinkage, and from this we know TPC, we know the sinkage. So we get W is equal to the weight that is to be added. So in this case it comes out to so many tons. So this will give you the amount of weight that is to be added totally to the ship. Now we need to, in this, the additional thing is we need to figure out how much is to be put in one hold and in the other hold, okay, two holds. Now let us consider the initial case. Okay. Now once you add this W, first usually we do not do, means in the previous couple of sections we did this problem in, if you remember, in the previous couple of problems, means 2-3 classes back, we were doing problems related to you are given the initial trim, some weight is added, what is the final trim, okay, or a final draft. We are finding the final drafts in which we added the trim and the sinkage and we got the final drafts after and forward. We have done that. So same thing we are doing backwards. So here let us see the change of trim. This formula has been used many times. So it's, I will just write it, moment changing the trim divided by MCTC. This formula is there. Now how do you find the change of trim? Actually this I think I confused it, I said change of trim for a couple of things probably. Let me see, 1 minute. Now okay, here I told something in a wrong way. This, I think I will repeat this at least 2 times now to make sure that you do not make this mistake in exam, because what I told right now was that see, that is in all these equations there is a small t coming, okay, which is a trim, and actually I told this in the beginning, then I made the same mistake myself. So then there is something called as a trim and there is something called as a change of trim, okay. It is like this, that is what is trim? See, in this expression we used, yes, here we used a t, this is a trim. Trim is the difference between your forward and back, that is trim, that is not change of trim, that is just trim, okay. So that is the first thing, and so this small t they are representing here is the trim itself, not the change of trim. Now the trim initial minus trim final is what we call as change of trim. Okay. So, actually this itself I said as change of trim, I think I repeated that. At any case, this is the trim, not the change of trim. This is trim 2, trim initial, then load is added, you get trim final. The difference between the two, this minus this, will give you the change of trim. That I think that it can you can make a mistake. So that's why I am writing anywhere T represents trim. There is no symbol or anything given for change of trim, it is written always as change of trim. Just know what is the difference. Trim is the difference between the forward and aft draft. Actually, there are a couple of things. First of all, there is a draft, okay. Then there is a draft, then there is a draft in the forward and backward side, which are different. That is the second thing. I mean, till now initially we always talk about draft as one thing for a ship. Then we see that the draft is different for the front and the back of the ship, I mean the aft and forward of the ship. That is the first thing. Then the difference between these drafts is what we call as trim, and then when you add and remove cargoes from the ship, the trim itself changes, okay. That produces a change of trim. So, that I think is the whole series of things. So, in this case, first the change of trim can be calculated as like this. I mean, it is obvious, that is, see, we have here change of trim is like this, 12.26 minus 11.48 will give you the initial trim, 12.1 minus 11.9 will give you the final trim. So, it will be 0.78 minus this 0.2, that is 0.58, which is 58 centimeter. So, 58 centimeter is the change of trim. Okay. Then now this formula is for change of trim. Change of trim, which we can imagine itself, change of trim is equal to the moment changing the trim by MCTC. Okay. That all right. Then now what is the moment changing the trim? That is the only thing we need to, like the left side we know 0.58, wait, change of trim is also in centimeters. So, 58 is equal to, now what will be the moment changing the trim? That is, let us suppose that that is what, let us suppose that W is the weight that you are putting in hold 1, then we know that a total weight of 339.2 tons has to be added. We have just calculated the total weight that needs to be added. That means, let us suppose that W tons you are putting in hold 2, that means 339.2 minus W of weight we are putting in the hold 5, the 2 holes. Now, as a result of which, what will be the moment that you have to calculate? That is the, I guess, the only thing you have to think of in this problem. So, now the 2 holes you are told, one is 30 meter forward of AP and one is 100 meter forward of AP. Now, another thing, when you are taking moments, do not take it about AP. It actually you might get the answer. Let me see. No, you will get the answer, I think. You will get
so, but in this formula, moment changing the trim, we have to take it about center of flotation.
You have to take it about the center of flotation. I am wondering, will you get the answer if, I do not think you will get the answer if you take it about AP. You have to take it about the center of flotation, right? Yeah.
Well, actually, the distance is from the center of flotation.
Which distance?
I mean, this total W into this, the center of mass.
No, I see that, but what I was thinking is, will you, no, it will not come. You have to take it about center of flotation only. So, you see, you have to 58, so 58 is equal to let us say W is, so that is next thing, only thing in this. So, every distance is given from AP. In this case, you are told that your hold number 2 is, hold number 5 is somewhere here, it is 30 hold number 5 is 30 meters forward of AP and hold number 2 is 100 meters forward of AP, 100 meters forward of AP. Okay. Now, you are also told that the LCF is 64 meter somewhere here, F is somewhere here 64 meter. Therefore, you have to take distances in a different fashion. It will be yes, W into one weight, let us say if it is added here, W into, okay, they have said here W into 34 minus or minus, yes, minus 339.2 minus W into 36, yes, that is correct, divided by 120. What is 120 divided by MCTC? Okay, that is given, MCTC is given 120. Okay, then so this is all. $34 into that and minus this. One of them is positive, one of them is negative. Okay, so that is okay. Then so you will get your W here. Okay, this will give you your W. Then you will get W is equal to, in this case, 264.2 tons. Okay, so that means you need to put 264 tons in the hold 2, I think, hold 2. Okay, which then it's just in the hold 2, and the rest of it, which is some 75 tons, you put it in hold 5. So this is the way to distribute the problem. I mean, distribute the cargo, which that's the problem. Okay, then so I guess of course you should do these problems. Okay, this book you all have, right? So you need to do these problems before the exam definitely, and if you have the concepts clearly, I think you can do all this. Like it's very sensibly only. The only thing is you have to know what is change of trim. You have to all those things, and these formulas, of course, definitely you have to remember these formulas, like change of trim is equal to moment changing trim by MCTC. All these things, once you have it, it's okay. And usually for exam also, I will take problems only from this. I am not going to devise my own problems mostly. I mean, even though I asked the problem straight from the book this time, most of you seem to be as if you have never heard that problem at all, right? All of you seem to be, I mean, reacted as if the problem was entirely new. You have never heard of that problem, and of course that nobody has said that 1.75 and what was it, 7? If you remember, 0.25, 0.75, that nobody has done. So it kind of looked as if it's completely new. Huh? How? That's what. Yeah, you just didn't do. That's the thing. Okay. Actually, the second part, this part is second part, means the end semester will be. It's not like the first part. Means first part I could ask questions like what is LCF, what is what all those, like there are things like that. Here there is nothing like that. It's only problems. Okay, so I think you will just have problems most likely. You won't even have any theory, nothing, and even there is nothing to ask like what is statical stability, nothing. It's all just problems. Okay, so I mean you just have to know the whole thing completely this time, otherwise you will have. So this time make sure you do and I won't ask anything outside this. So just make sure you do these problems. So that means 50 marks of problems you will have to, that will be a lot of problems. So okay, then there is one more similar problem that is slightly different. Okay, now you are in this problem. You are told that there is a vessel of length 200 meters and you are given its half ordinates. So you are given the half ordinates of the vessel like this: station, half ordinate, like this you are given. You know what are half ordinates? When you are given the ship like this, I mean if you are given the ship like this distance is known as a half ordinate. So one like this you have the half ordinate. Okay, then you are given a couple of hydrostatic data, you are given that up to 11 meter, up to 11 meter, the underwater volume del, that means I guess the draft is 11 meter probably. We will see that up to a water plane of or water up to a water plane of 11 meters or water line of height of 11 meters, you are told that your underwater volume is something that is 64,300 meter cube. You are given some hydrostatic data Kb, Kg, now you are told, you are asked to find the change of trim. So, I guess this has a trim, as it is standing also it must be having a trim. Now, you have to find the change of trim if a weight of 500 tons is shifted 60 meter from aft to forward. So, a weight of how much 500 tons is shifted from 60 meter, okay, from aft to forward. From aft to forward, a weight of 500 tons is shifted a distance of 60 meters. So, moment changing trim you know directly 500 into 60, that is a moment changing trim. MCTC is that is a question, find the MCTC. Okay, so, this is a question. So, what we should understand is, looking at the problem itself, we can see that directly you are given the moment changing trim and you are asked the MCTC. So, what you will definitely need to find is your change of trim. Okay. So, that is going to be what you are going to find, change of trim. Now, what do we need to find change of trim? Let us see. Change of trim, actually there are a lot of formulas. So, for change of trim, let me see all the you have to just look back at all the formulas that you have for change of trim. Actually there are a couple of formulas. The one, I think the most common one that we have used is this, that is the change of trim. There is a formula given like this. Okay. Now, we have done this. So, change of trim, one formula was given like this, where L, capital L is the length of the ship, W is the weight that is shifted, given here 500 tons, D is the distance through which it is shifted 60 meters, capital W is the weight of the ship. Okay. Total weight of the ship is the density of sea water into the volume under 11 meters, that is also given. So, the problem comes down to finding GML. Okay. 11 meter is not given as a draft, but I am going to assume it is a draft, otherwise you cannot do it. So, it is not, it must be 11 meter must be the draft. Yes, it is given actually 11 meter is the draft. Okay, 11 meter water plane is the draft. Okay. Then so, the problem is to find GML. Okay. Now, to find GML, what do we need? GML, we are given couple of hydrostatic things Kb, Kg. Let us see, KML is equal to BML plus Kb. Okay. Kg is given, therefore, KML minus Kg will give you GML, right? Right. Therefore, what we need to find is GML, Kg is given, therefore, we need to find KML. Now, KML is BML plus Kb, Kb is given, therefore, our problem comes down to finding BML. Now, BML is I by del, right? Therefore, del is known, therefore, our problem comes down to finding I. So, but note one thing, this is BML, that means I is the center of it is the moment of inertia about the transverse axis through the center of flotation, which we call as barycentric axis. Okay. So, I is about the barycentric axis. I think there was something, what was the definition? Some symbol was given for I through the barycentric, IF probably, I do not know, I will call it IF now. there is a symbol for I through the it is here it's given as IF. Okay, anyway we will put it as IF. IF is the transverse moment of inertia through the center of flotation. So this comes down, this is what you have to find. Okay, now okay, so let's start from the beginning. So you are given the half ordinates of the, that's why you are given the half ordinates, okay, to find IF. So you are given the half ordinates and you are told that means it's like this, different stations you are given the half ordinates. So we will make the table like this: station, half ordinate, Simpson's multiplier, then you will have a function of area, then we use a lever, then function of first moment, then another lever, then function of second moment. This is to find the IF. So station, so first of all it's like this, 1, you are given the half ordinates 10. So let us do 1 4 2 4, Simpson's multiplier, 1 4 2 4, like this you will go. Then function of area, it's just y dx. So this into this, okay. So this will become 40, this is 0, so this is 0. So 10 into 4, 40, like this. Now lever you have to put, means you can put half perpendicular as 0 and 1 2 3, like that each station you can put successive levers 1 2 3. This is to find the we are finding the IF, that is I about the yes. So you need to find, no, that is the thing, you will have to do this. See, we do not know where the center of flotation is, therefore you have to do a couple of things. First of all, we will use this formulas. IF, this is what we have to find, okay. This is the only way to do it. So IF, I through the center of flotation, will be I about the half perpendicular minus A x bar square. Therefore we need to find I about the half perpendicular first, then we need to find x bar. A is the water plane area, x bar is the centroid of the water plane area, which is your center of flotation. This will give you I about the center of flotation, right. Okay, that's, so we will follow this for 40. So we are going to take lever from the half perpendicular only, so we will proceed like that. This we will go 0 1, so this will be 0, like this will become 40. Now again the same lever, this will give you your second moment. Similarly you this, let me write the third one also, second will become 13.0, this becomes 26, you multiply it with the lever, it becomes 52, you multiply it with the lever again 104, sorry, 104. Okay, so so like this, the now that means in this you need to find three things: A, the area, you need to find x bar, the centroid, and 3 you need to find IAP, I about the half perpendicular. Okay, so 3 things we need to find, and as a result of which we can get IF. So this, okay, next is very straightforward once we know this. So A will be 2 by 3 h into sigma, this is the only thing. A is, see here we have the function of area, so from that you can, from this total we can get the, let us call this 1, from this total into sigma of 1 will give you the this one, this will give you the total area, whatever they get. Then x bar, the centroid will be the first moment divided by the area. Okay. So that is the next thing. So x bar is the next step, it is equal to 2, so this 2 by 3 into h into sigma, let us call this second sum, this sum let us call it as 2 and this sum let us call it as 3. So, this sum of 2 divided by this area that we got, okay, which actually becomes 2 by 3 h into, wait, centroid will be, that will give you the first moment. First moment by, is it by area or is it by function of area? 1 minute.
So it is by area, otherwise the 2 by 3h will not come. So if you remove 2 by 3 into h, then it will be function of moment by function of area.
No, here they have actually sigma area, they have the function of area, not the total A. That seems,
So total moment by area, that's the
total moment divided by total area, that is fixed anyway. So, total moment is this divided by the total area. What they have is 2 by 3 h, I think it is a mistake, it must be, but they have done it actually, they have, I think it must be a mistake, because they have a, they do not have 2 by 3 h here, they just have Simpson, I mean
function of moment you have already
it anyway, even dimensionally it won't be correct. H function of area,
so it's correct.
no, this is correct, no, okay, that is correct. So, this it should be A only, it means in the previous section here we have actually found the area. So, it should be like this only. So, this 2 by 3 h into sigma of 1 should come at the bottom, the whole thing should come at the bottom. Here you will have 2 by 3 h. So, that means the book there is a mistake, it is, they have taken only that. Okay, then, so this will give you the x bar, okay. Then I what was the expression for I? We derived some expression actually. Second moment, h square or h cube? Is it h square what we derived long back? Here it is given h cube. H square is given, so that will be square.
Sir, actually the dimension is length to
Dimension is length to the power 4, okay.
so sir here h square,
H square,
area into liver.
area into liver, I do not know, they have h cube here. Actually there are, that is what, when you are doing this be careful, there are mistakes in this book. It is not like the other book that Brian's book, that is very good, that is, but this has a lot of mistake. I don't, yeah, I think it is h square, otherwise dimensionally it is not correct. So, this is h, okay. So, we will write it as, is it 2 by 3? 2 by 3 h square into sigma f of second moment. Okay. So, 2 by 3 h square into sigma, if, so this will give you IAP, and therefore, our problem becomes IF is equal to just IAP minus A x bar squared. Okay. So, this will give you your IF, and now you just go back. So, once you have IF, you will get your GML, you have to find GML, and from GML you find the, from the change of, you finally find the change of trim, and I think your question is to find MCTC. So, we already have the change of trim. No, okay, once you have G0 moment, actually I forgot what we did. Change of trim, MCTC is equal to weight we have, okay, GML we have. Now, MCTC is equal to W into G0 ML by, I think there is, are they using another formula there? W into G0 ml by L is MCTC, right? Have you used a formula like this? I am trying to change of moment changing trim by MCTC is equal to change of trim. Okay, yeah, okay, that you can do. W into G0 ml. Where is that 100 coming? W into G0 ml by L will give you in meters, so you have to divide by 100. Okay, now you just do the same thing. Change in trim is equal to moment changing trim divided by, yeah, that's a good thing. Change in trim is equal to moment changing trim divided by MCTC. Therefore, very straightforward, you can calculate the moment changing trim. Oh, sorry, what did I write? Wait, something else. We have already calculated the change in trim as W into D, right? Have we calculated then? What? No, this problem is different now. Oh, okay, this is very straightforward. Oh, sorry. Yes, okay, I'm sorry. So, this is just a very simple problem. I mean, this part is simple. You are told that the 500 tons is shifted 60 meters, okay, from aft to forward. It's already given. So, there is nothing. The moment changing trim is already given. So, moment changing trim is just that 500 into that 60. So, this will give you the moment changing trim divided by MCTC. We do not know, is equal to BML, GML. We got GML. What is this? 500 by divided by MCTC is equal to change in trim. W is equal to, yes, okay. Keep cutting. L into W into D divided by W into GML. Okay, that's what. So, this will give you your result. Okay. So, I guess the only thing to do here is to find GML. Okay, the only thing to do here is finding the GML in that elaborate fashion. That is the only part of this problem, and there are actually a lot of formulas in this, too many formulas in fact. Change in trim, moment changing trim, so that you have to keep in track when you are doing the exam, when you are doing for the exam. I think the best thing is you definitely have to do these problems. It's not possible to really do all this without okay, you can do it, but you definitely should do these problems. Okay, so I think I'll stop here. Okay, thank you.